Graph the function y equals 1/2 x minus 4 quantity squared plus 3 and state the domain and range. The first thing we're going to do is think about the base function y equals x squared. And that would look something like this. It'd be a parabola, pretty skinny parabola with its vertex at 0, 0, right at the origin. We'll make this the origin right there. Okay, we have some transformations here. So I'm going to write this just a little bit larger so we can look at these numbers. Y equals 1/2 times x minus 4 quantity squared plus 3. All right, first of all, let's look at moving the parabola. We're going to move it left, right, up, and down. That's the first thing we're going to do. So I'm going to look in here first, inside the parentheses, and by the way, it has to be in this form first. If it's not, look at the procedure to complete the square so that you can get the equation into this form. Okay, now when we have a negative, x minus something, inside the parentheses, that means we're going to move it to the right. So I'll just write a little key here. Negative, because we have a negative 4 there, that means move the vertex to the right. Okay, to the right. So I'm going to take this this vertex and I'm going to move it to the right 4 places. Okay, so far we're right here. I'm just going to make a tiny little dot. I'm right there. But also we have to consider this. And this doesn't go in the opposite. Kind of this inside the parentheses goes in the opposite. You know, negative goes to the right and positive goes to the left. But outside the parentheses here, this just plays it straight. This is a positive 3. So this, I'm going to put a note up here. The positive means to move it up. So I'm going to take that vertex and move it up 3 places. So now this is our new vertex place. Okay, we also have this you could call it a multiplier or a scaling. It's 1/2. So it means the parabola is going to be, you can think of it as being 1/2 as high, although this goes on forever upward. You can think of this as being 1/2 as high. So it's going to say 1/2 as high. And I'm going to put that in quotes, the almighty quotes, to say it kind of means that. Meaning it grows half as quickly. Okay, we're ready to graph just a rough sketch of this. So this was our original parabola. And now we've got our new vertex. And we're going up half as high. So here when x was 1, we went up 1 unit. Well, here if we go to the right 1, we're only going to go up half a unit. Okay, and if we go over 2 spaces from the vertex, we'd go up 4 in the original. But here we're going to go over 2 and only go up 2 units. So same thing on the other side, because, you know, a parabola is symmetric. So you can think of it as growing half as quickly. And it does still curve. We get that. And if you really zoomed out on these, they would look similar, but one is just wider than the other. So there's a rough sketch of the moved or transformed parabola. We also have the domain and range. So let's just put that down right now. The domain is all of the available x values. And we can see that this is going in both directions, to the right and to the left. So our domain is all real numbers. Negative infinity, comma, positive infinity. That's how you write the domain in set notation, or all real numbers in set notation. Range, we can see what the range is. That is, it's going to be cut off at this point, at this. This is not part of the graph. I'm just doing this for teaching purposes. It's cut off there. Y does not get lower than that. It does include that, but so I'll put that right there. We include 3 in the domain, but it goes up forever, and we denote that with infinity. Okay, so we have the domain, the range, and we've graphed a rough sketch of the transformed parabola.